Hello everyone, welcome to my channel. In this video, we will learn about list and data frame objects. Unlike vectors, matrices, and arrays, we can store different types of data in a list, or a data frame. We can also consider a list like a vector, because it is linear. But unlike vectors, each component of a list can contain different types of objects. We can use the list function to create a list. For example, student is constructed by using the list function, then we added names attribute to each component, by using the names function. Alternatively, we can create a list, and add the names attribute at the same time. Like a vector object, the name attribute is a standard attribute of a list object. In this newly created list, both name and class taken components are character vectors, but year and GPA are numeric vectors. When a list is printed, a $sign is printed, before the name of each component. Since both vectors or lists are linear, we can apply functions that are used for vectors, for a list, such as names and length functions. We can even store a list within a list. For example, the first component of this list is a numeric vector of length 1, the second one is a character vector of length 26, and the last component is a list that has two components. Recall that we can use the str function to display an object in a compact form. This function is especially useful for displaying a list object. To convert a list to be vector, we can use the unlist function. We can use the C function to concatenate lists. In this example, the first argument of the C function is a list of length 2, and the second one is a list of length 1. Using the C function to combine these two lists, create a list of length 3. The components of a list are numbered, based on their creation order. We can select one or more components from a list, by specifying their position numbers. There are several ways of accessing an element of a list. Using single brackets returns a list. In this example, we use a pair of single brackets, to extract the first component of students. The returned result is a list object, containing only one element. We can also use double brackets, or the $sign operator, to extract a component from a list. Using double brackets or a $sign, return the internal content. For example, since the first element of the list is a vector, using double brackets or a $sign would return a vector. If the first element is a matrix, it will return a matrix. To use the $sign to access a list component, this component needs to have a name. This example shows how to access the first element of the class taken component. Using the double brackets, returns the class taken vector. Then we enclose 1 within the single brackets, to return the first element, which is PM510. The second method is using the $sign, instead of using double brackets, to access the class taken vector. Then we enclose 1 again within the single brackets. We can also access more than one component from a list, by using single brackets. In this example, we select the third and the 4 components from this list. This command generates a list object with a length equaling 2. On the other hand, we cannot access more than one component from a list, by using double brackets. A data frame is a collection of data, that is organized in rows and columns. Rows refer to observations, and columns are variables. A data frame is a special case of the list object, because we can store different data types in a data frame. Unlike a list, each component of a data frame is a vector with the same length. To create a data frame, we can use the data frame function. To convert an object to a data frame, we can use as .dataframe function. For example, to convert a vector to a data frame, the vector will become a one-column data frame. Converting a matrix to a data frame, the matrix will become a data frame with the same dimension. We can also convert a list to a data frame. In this case, each component of a list needs to be a vector, and these vectors should have the same length. A data frame is a special case of the list object. We can verify this property by using the type of function. The names attributes are column names or variable names of the data frame. But unlike a list object, a data frame has row names attribute. It also has a class attribute with a value of data frame. A data frame object shares the common properties of a matrix, because both have two dimensions. Remember that we can use callName function to access the column names of a matrix. We can also use the callName function to access the column names of a data frame. Similarly, the row names function can be used to access the row names of a matrix and a data frame. Since a data frame is also a special case of the list object, we can use the names function to access the column names as well. By default, if we are not assigning row names to a data frame, the default row names are assigned. For example, the default row names for the data frame D are 1 to 5. Notice that these numbers of row names are actually character types. Instead of using the default assigned row names, we can assign row names of a data frame with something more meaningful, such as subject's ID. Recall that we can use the length function to count the number of components of a list. Since a data frame is a special case of the list object, we can use the length function for a data frame as well. Applying the length function to a data frame returns the number of columns of a data frame. The functions that are used for a matrix, such as ncol and nrow, can also be used for a data frame, because a data frame shares common properties with a matrix as well. Since a data frame has 2 dimensions, we can select components of a data frame, as we did for a matrix, by providing 2 indices. This example selects the first 3 rows, and first, third, and fourth columns of the data frame D. Remember that we can use the $sign operator to select a single named component from a list object. Since a data frame is a list, we can use a $sign to select a single column, or a variable from a data frame. The first 2 examples select live on campus and sex variables. The last example selects height variable, but only keeps the first 3 elements of the height variable. We can use the cbind function to combine data frame column-wise, just like we did for combining matrices column-wise. The number of rows of combining data needs to be the same, however, the row names of the data frames can be different. The row names of the first data frame are used in the combined data. We can also combine data frames by rows, by using the rbind function. To use the rbind function, the number of columns of each input data frame must be the same, and the names of the columns must be matched as well. In some situations, we might want to add 1 or more variables to an existing data frame. One way to add variables is to use the data frame function. In this example, we create a new data frame, D4, which includes previously created data, D, and 2 newly created variables, height mean and weight mean. If we just want to add new variables to an existing data, instead of creating a new data frame, we can just use either the $sign operator, single brackets, or double brackets to add new variables. These examples add height mean and weight mean variables to the data frame D. Most of the time, a data frame is generated by reading an external text file. We can use the read.table function to read an external text file. The columns in the text file need to be separated by 1 or more separators. The result from the read.table function is a data frame. The read.table function has a large number of arguments that we can use to read a file with different formats. Most of these arguments have their default values. We only need to remember a few commonly used arguments. Before we read an external file, we need to understand how the external file is formatted. The default separators for read.table are spaces, tabs, new lines, or carriage returns. For any other types of separators, we need to specify them in the sep argument. If the external file has variable names, we need to set the header argument to true. The read.table function can recognize NA as a missing value for any data type. If we have a special symbol that is represented for missing values, we can specify it in the na.strings argument. By default, the read.table function treats any text after the $sign as comments. To change the default option, we can use the comment.char argument. Furthermore, the skip argument is to skip a number of lines when we read the input file. And the nrow argument can be used to specify how many numbers of rows we want to read. This option is useful when we read a large file. For example, we can start reading a few lines first, to make sure the external file can be read successfully, before we remove the nrow option. Let's see how to read this text file. Columns in this text file are separated by tabs. The first 2 lines after the $sign are comments. There is a header line that contains the variable names. The numerical missing values are represented as periods. Before reading the file, we can change the working directory, where the external file is located. In the read.table function, the header argument is set to true, since variable names are in the external file. We don't need to specify the comment.char option, since the comments are written after #, which is the default option. The na.strings option is set to a period in order to read the missing values correctly. The sep option is not specified, since read.table can read tab-separated file by default. There are other similar functions for reading text data, such as read.csv and read.delim functions. These functions are basically the wrapper functions of the read.table function, by setting some arguments to some commonly used values. For example, read.csv reads the comma-separated value files. This function sets the header to true, and the sep argument to a comma. The read.delim function reads tab-delimited files, and set header to true as well. To write a data frame to an external file, we can use the write.table function. The file option in write.table is to specify the name of the output file. By default, the character columns will be surrounded by double quotes in the output. We can set the quote option to false to remove the double quotes. The sep option is to specify what separator to use to separate each column in the output. By default, missing values are written as NA. But we can use the NA option to set what value to represent missing values. By default, both row names and column names are printed. We can set row.names or col.names to false if we don't want them to be printed. In this example, we are writing dat1 to an output file. We didn't specify any values to the previously introduced arguments, except for the file argument. Notice that the default row names, 1 to 6, are written to the output file. All the character values, including row names and column names, are in quotation marks. Columns are separated by one single space. The missing values are printed as NA. Now we change a few options, such as setting both row.names and quote arguments to false, using the tab symbol for the sep argument, and using a string of length 0 to represent missing values. The advantage of creating output in this format type is that we can easily open it by using Excel, and it can be easily imported by using other software. Now, let's review what we've learned from this video. In this video, we learned how to create lists and data frames. Unlike vectors, matrices, and arrays, both lists and data frames can store different data types. Since data frames share some common properties with matrices and lists, some functions that are used for a matrix or a list can also be used for a data frame. Lastly, we learned how to create a data frame by reading an external text file, and how to write a data frame to an output file. Please like and subscribe to my channel, and click the bell icon to get new video updates.